Hello everyone. Right, so this video we're going to be talking about sample spaces. So in this video we're going to be going over the two-way table and the tree diagram. So what is a sample space? A sample space is just a list of all possible outcomes. So for example, the sample space for rolling a dice is 1, 2, 3, 4, 5, 6. I can get 1, 2, 3, 4, 5, or 6. That is considered a sample space. So, another thing to know is all probabilities in a sample space have to sum to 1. So all probabilities in a sample space have to sum to 1. That makes sense, because look, here's my sample space of my outcomes for rolling a dice. I have a 1 in 6 chance of getting a 1, 1 in 6 of getting a 2, 1 in 6 of getting a 3, 1 in 6, 1 in 6, 1 in 6. They all add together to get 1. Right, so that's always true. So we're going to look at two-way tables. So two-way tables are a good way of listing out outcomes of two events happening. But let's just look at this one. This one's just a wee bit different now. So this one here is consider the following two-way table representing the number of students who either play sports or participate in music. Fill in the missing values above and answer the following questions. So 25 boys play sports, 15 and participate in music. In total there are 40 boys. That makes sense, right? So let's kind of fill in the gaps here. I noticed this gap here, 40 plus 50 has to equal 90. So that's going to be 50. And then 30 plus blank is equal to 50. That's going to be 20. Now 15 plus 20, that's going to be 35. 25 plus 30, that's going to be 55. So there we go, all done. So I can see here, 30 girls play sport, 20 do music, and there are 50 girls all together. So what's the probability of randomly selecting a student who's a boy who plays sport? So what's the probability of a boy playing sport? That's going to be 25 over 90, which will break down to something. 5 over 18. What's the probability that a randomly selected student is a girl who participates in music? So a girl who participates in music, so that's going to be here. So it's going to be 20 over 90, which is equal to 2/9. And then the probability are playing sports and participating in music mutually exclusive for these students. Explain. So is playing sports and are playing sports and participating in music mutually exclusive for these students? Like, no, because you can play sports and you can participate in music. So, but for these students in particular, they don't really tell us if they play both. So can you play sport and participate in music? In this case, I'm inclined to say no. So obviously this school is saying you either play sport or you play music, because if there's only 40 boys and 50 do music and 25 do sport, well then you can't really have a boy who does sport and music. So that's an odd question there. So let's look at some papers now. So this is from the 2022 paper. So the table below shows a breakdown of the animal by shelter, by type, animal, cat or dog, and by sex, male or female, on a particular Monday. Complete the table by filling in the 4 missing values. So again, filling missing values here. 14 plus something is equal to 40. That's going to be 26. 11 plus something is equal to 26. That's going to be equal to 15. 9 plus 15 is 24. 5 plus 11 is 16. Gorge. Filled it out there. 3 different animals, part C now, 3 different animals are picked at random from the shelter on this Monday. Find the probability that the first animal they picked was a cat. So the probability of a cat. So that's probably picking a cat. Well, how many cats are there? There's 14 cats and there's 40 animals in total. So it's going to be 14 over 40, which is going to break down to 7 over 20. Find the probability that all 3 animals picked were male dogs. Give your answer correct to 3 decimal places. So, this is a funny one. This one's a funny one, because find the probability that all 3 animals picked were male dogs. So what's the probability of being a male dog? 11. So there's 11 male dogs. So there's 11 male dogs. So the probability of male dog, male dog, male dog, right? These are mutually exclusive. Not mutually, these are independent, so I can just times their probabilities together. But look here, so if I was picking a male dog first, it'd be 11 over 90. No, not 90, what's it here? 40. It'd be 11 over 40 for the first dog. But now I've selected that dog, right? So if I picked another animal, there's one less male dog in the mix. So now I have 10 male dogs. So that'll be 10 over 40. And then the last one, once picked, so it'll be 9 over 40. And that will be... So 11 times 10 times 9, 40, 40. That's going to be equal to 99 over 6,400. That's the probability of 3 male dogs. That's probability of picking 3 male dogs in a row. So correct answer to 3 decimal places. So that's going to be 0.015. Alright, let's look at the next question here. An experiment consists of throwing 2 fair standard 6-sided dice and recording the sums. This is from the 2018 paper. The totals are shown in the table. Complete the table. So 4 plus 3 is 7. 4 plus 4 is 8. 5 plus 2 is 7. 5 plus 5 is 10. 6 plus 1 is 7. 6 plus 6 is 12. There you go. Bada boom, bada bing. Find the probability of getting 7 or 11. So probability of 7 or 11. So remember, addition rule. If I see or, I'm adding. These are mutually exclusive events because I can't get 2 numbers that add up to 7 and 11. So the probability of 7 plus the probability of 11. That is going to be, the probability of 7 is 1, 2, 3, 4, 5, 6. That would be 6 over 36. Plus probability of 11 is 1, 2. So it'll be 2 over 36. And that's going to be 8 over 36. Which is going to be 4, 4, 2 over 9. So the probability of 7 or 11. 2 over 9. Find the probability of getting a total which is a prime number. So remember, a prime number is a number that cannot be... A prime number is a number that's only divisible by 1 and itself. 1 is not a prime number. So for example, 2, 3, 5, 7... they're all ones, 11, 13, right? So they are most of my prime numbers there. So what's the probability of getting someone that's a prime number? Let's highlight them. 2 is a prime number. 3 is a prime number. 5 is a prime number. 7 is a prime number. 8's not. 9 is not because 9 is divisible by 3. 10 is not. And 11 is a prime number. So how many prime numbers do I have? We count my yellow squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 out of 36. That's the probability of getting a prime number. Right. Part B. A card distributor sells Ford and Renault cards. If it has 30 cards for sale on a particular day, 18 of Ford cards, 12 are Renault cards. 7 of the Ford cards are red. 4 of the Renault cards are red. 1 of the 30 cards is chosen at random. What's the probability the car chosen is Ford car or car which is not red? So the probability of it being a Ford or not red. So this is actually a separate question. This is actually a mutually exclusive question from the previous section. So they added on as a part B here, so I might as well answer it. If I was any smarter, I would have snipped this part and put it in the previous section, but oh well. So probably Ford or not red. So are these mutually exclusive events? They are non-mutually exclusive because I can get a Ford car that's not red. So I'm going to use my addition formula here. So it's going to be probability of getting a Ford plus the probability of getting a non-red car minus the probability of a Ford and a non-red car. So that is going to be probability Ford. What's probably getting a Ford is, well, there's 30 cars, 18 are Ford. So 18 over 30 is probably getting a forward, probably getting a non-red car. So how many cars are red? Let's have a look here. 7 of the 4 cars are red, and 4 of the Reynolds cards are red. So therefore 11 cars are red. There's 30 cars in total. Therefore it's 19 cars that are not red. And then what's the probability of a Ford being a Ford and not red? So how many cars are a Ford and not red? Well, how many Ford cars aren't red? Well, if 7 Ford cars are red, and I have 18 Ford cars in total, therefore 11 out of the 18 Ford cars are not red. So put this probably in. That is going to be 26 over 30, which is 13 over 15. So the probability of getting a Ford or a non-red car is 13 over 15. So that was a tricky one. That was a really tricky one, right? And that was more mutually exclusive. So if you want to watch that, it's another video. Right. Finally, let's look at this last question here. So, and this is from 2021 or level paper. So the game Twister is played by using 2 spinners and a mat with coloured spots. The 2 spinners needed for the game are shown below. Both consist of 4 equal sectors. A player spins both spinners and must then place their selected hand/foot on the selected coloured spot on the game mat. The spinners below show the outcome right hand and on a yellow spot. So right hand on a yellow spot. How many different outcomes are there for this game? So this is just asking us for how many outcomes there are. So we could do fundamental principle of counting. Right, only asking for how many different possible outcomes. It asks us to list them. How many different ones? Well, for my first spinner, I have 4 options. And then for my second spinner, I have 4 options. So I have 16 total options or possible outcomes. Right? But I have a feeling a two-way table will help me for the next few questions. So let me draw out a two-way table of these outcomes. So this is going to be the first spinner. This is going to be the second. Excuse me, wow. So I have right hand, left foot, right foot. Then I have red, blue, yellow, green. So I have here, I can get red and a right hand. I could get red and my left hand. Let's just sort of flip it here. Wait a minute. So I can get my right hand and red. I can get my left hand then red. I can get my left foot then red. I can get my right foot then red. I can get my right hand and blue. I can get my left hand and blue. My left foot and blue. My right foot and blue. My right hand and yellow. My left hand and yellow. My left foot and yellow. And my right foot and yellow. Yeah, and if I count my outcomes here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So did I say 4 by 4? What am I missing? Green. I'm missing green. Sorry, I'm missing green here. Last one. Got scared there for a minute. I could have my right hand and green, my left hand and green, my left foot and green, and I could have my right foot and green. Right, and then if I count all the outcomes there, I get 16. Right. So Kate spins each spinner once. What's the probability she must use her left foot? So, what's the probability that she uses her left foot? Right. So let's look how many outcomes she has when she's using her left foot. She has Well, 1, 2, 3, 4. So she has a 4 in 16 chance of using her left foot. So 4 in 16, which is 1/4. What's the probability? What's the probability she has to use a red or a yellow colored spot? So red or yellow colored. So let me just go highlight my red ones now. So I can have my right hand in red, left hand in red, left foot in red, right foot in red, and I could have my right hand in yellow, left hand in yellow, left foot in yellow, right foot in yellow. So I have 8 outcomes there. So it'd be 8 over 16. So the probability of red or yellow, 8 or 16, which is 1/2. Finally here, Jack spins each spinner once. What's the probability that the outcome is his right hand and blue spot? So what's the probability of him getting right hand and blue spot? Right hand blue spot only appears once, so he has 1 in 36. Again, or you could also use your rules of probability. This is an independent event, and means multiply. So probability right hand and blue. That's the probability of a right hand times the probability of a blue, which is probably getting your right hand is 1/4 in the first spinner, and it's 1/4 in the second spinner to get blue, which is 1 in 16, which matches up if I checked it with my two-way table. Then his right hand or a blue spot. Again, so you see the word or, you can think addition, so we could do our addition formula. So probability A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So that probability A is right hands, the probability of right hands, plus the probability of getting a blue, minus the probability of getting your right hand and blue. Well, I got this one from the previous question, which is 1/16. So that was going to be 1/4 plus 1/4 minus 1/16. Which is going to be equal to 7 over 16. Right? Probability of right hands or blue. So, but then if I look at my little table here, let me make a note. Let me put blue color. So right hand or blue. Well, I can have right hand in red. I have right hand in red, right hand in blue, right hand in yellow, right hand in green. Or I need something with blue. So my left hand in blue, left foot with blue, right foot with blue. How many blue squares do I have here? 1, 2, 3, 4, 5, 6, 7. I have 7 over 16, which matches up with my probability here. Right. Next now, let's look at some tree diagrams. Right? So a tree diagram is a way we can calculate probability for 2 or more events, or 2 more like kind of trials. So you see, two-way table is good for like if we have a kind of 2 trials. So like flipping a coin, dice. A tree diagram is good if we have more things, like flipping a coin 3 times. So let's just work by example here. So Kevin tosses a coin 3 times. List all of the outcomes with a tree diagram and answer the following questions. So they're asking us to list all the outcomes in a tree diagram. So the tree diagram, we start in the center here. Right, I could get a heads, I could get a tails. This is my first flip. Now in my second flip, I could get a heads, I could get a tails. Same here, I can get a heads, I can get a tails, I can get a heads, I can get a tails, I can get a heads, I can get a tails, I can get a heads, I can get a tails, I can get a heads, I can get a tails. They will rarely ask you to do a tree diagram for more than like 3 of them, because it just gets really messy after that. Right, so let's read my outcomes here. So I can have, follow the blue path, I can have heads, heads, heads. right? Or I can have heads, heads, tails. So follow the path, heads, tails, heads. I can get heads, tails, tails. I can get tails, heads, heads. I can get tails, tails, heads. Let's say tails, heads, tails. I can get tails, tails, heads. I can get tails, tails, tails. Right, list all my outcomes of the tree diagram. So, the thing with tree diagrams is, so here's a nice neater one for us to look at. The thing with tree diagrams is, right, I put my probability of the event happening on my line here. Right, so see my line here. So probably getting heads is a half, and probably getting tails is a half. Right, same here. My second toss, the probability is the same. We could run into problems where these probabilities end up being different for like the second or the third toss. So always to keep that in mind. I think there's an example in here, hopefully. So, but if I want to find the probability of the outcome here, I multiply all the probabilities I get along the way. So it'd be a half times a half times a half, right? A half times a half times a half, etc. So the probability of getting 3 heads in a row is 1/8. So, we want to know what's the probability of getting exactly 1 head. So 1 head, I can get heads, tails, heads, heads, tails, tails, heads, heads, tails, or tails, tails, heads. So I multiply the probabilities together using the fact that independent events, multiply the probabilities together, or I could just count them out. If I just count them out, I have 1 head here, 1 head here, 1 head here. It's going to be 3 out of 8, and that's what my question is going to end up here anyway. Probability of no heads, again, right? I can use my tree diagram to answer that. Probably no heads, well, that's going to be 1/8, right? Or we can use my logic here of 1 minus the probability of at least 1 head. Because if I got at least 1 head, if I subtract that from 1, the rest of them are the ones where I have no heads. Probability... Oh, sorry. First one is probability of getting at least 1 head. So, sorry, the second part... That was the answer to part C. Sorry, part C was 1/8. Part B is also the probability of getting at least 1 head. So, at least 1. So, I can get 1, I can get 2, I can get 3. Right? So, at least 1. So, that has 3, that has 2, that has 2, that has 1, that has 2, that has 1, that has 1. So, it's going to be 7 out of 8. 7 out of my 8 outcomes have at least 1 head. And then tails, tails, 1/8. And then tails, tails, heads. What's the probability of Kevin getting heads on his last throw? Right? So, we're looking for tails, tails, heads. Again, probably tails, tails, heads. There it is. What's the probability of getting tails, tails, heads? Again, it'd be 1/8, or you could do a half times a half times a half, which is equal to 1/8. Right, so let's just have a look at the exam question anyway. So this is from the 2016 paper. Right. This is from the 2016 paper. So Mandy wants to buy a ticket to the theatre. She can choose between the balcony or the stalls. She can go Monday, Wednesday, or Friday. For an extra charge, she chooses the VIP tickets V, where she will meet the band, or she can choose to see the show only, which is O. Complete the tree diagram and hence otherwise find the probability that Mandy chooses a VIP ticket on a Wednesday. So, this is my outcomes here. So, she can either go stalls or balcony. Okay, once she's choosing a seat, she can either go Monday, Wednesday, or Friday. And then finally, when she has what day she's going, she can go VIP or she can get the show only ticket. So let me fill this out. So she can get VIP show only, VIP show only. She can go Monday, Wednesday, or Friday. VIP show only, VIP show only, VIP show only. So let's list out all my outcomes here. So it's BMV. That's my first outcome. So balcony Monday, VIP, balcony Monday show only. It'll be balcony Wednesday V. Oh, I'm gonna have so many of these. I'm not listing all of these out. Right? I'm gonna use fundamental principle of accounting. I didn't realize how many it's just gonna be. Right. So, how many possible outcomes I have here? I just count the nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 total outcomes. I have 12 total outcomes. One of which we're looking for here. The probability. Complete the tree diagram. Find the probability Mandy chooses a VIP ticket on a Wednesday night. So she's looking for a VIP ticket on a Wednesday night. So let's highlight some stuff here. So VIP on a Wednesday. So it doesn't say balcony or stall, right? It doesn't say balcony or stall. So she can get a VIP on a Wednesday with a balcony ticket, and she can get a VIP ticket with a stall ticket. So it could be balcony Wednesday VIP, or it can be stall Wednesday VIP. So there are my two outcomes here. So I have two favorable outcomes. So the probability of that happening is going to be 2 over 12. So 2 out of my 12 outcomes have the options of the outcome of Wednesday and a VIP show. Right, this is from the 2013 paper. So an unbiased circular spinner has a movable pointer and 5 equal sectors, 2 coloured green and 3 coloured red. Find the probability that the pointer stops on green for 1 spin. What's the probability stops on green? Well, I have 2 green here, so the probability is 2 over 1, 2, 3, 4, 5, 2 over 5. List all the possible outcomes of 3 successive spins of the spinner. So we could list all the outcomes for 3 successive spins of the second spinner. So we could do the first spin, he can get green, or he can get red. Second spin, green, he can get red. Oh, it's gonna be. I have to do this 3 times. Right, make this bigger. And you know what? Learn from me. Start more center. I never start center. Right. Okay, he can get green for the first one, or he can get red. Then for the second row, he can get green, or he can get red. Green, ding ding ding, red. Green, ding ding ding, red. Green, ding ding ding, red. Green, red. Green, red. So he could get green, 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 red, green, red, red. He could get, so you can get green, red, green. You can get green, red, red. He could get red, green, green. He could get red, green, red. He could get red, red, green. And then finally he can get red, red, red. I think I'm right. 1, 2, 3, 4, 5, 6, 7, 8. I think I am correct in saying that. So 2, 2, 2, 8. Yeah, grand. So that's all my outcomes there with a tree diagram. Let's look at another one now. So there's a problem here. So see how in this question it was easy. It kind of helped us with tree diagram to really systematically list them all out. Exam styles. Natalie has 8 socks in a drawer. 5 socks are black. 3 socks are white. Natalie takes out a sock at random, writes down its color, and puts it back in the drawer. Then Natalie takes out a second sock and at random and writes down its color. Complete the tree diagram below. So the probability she picks a black sock. Well, there's 8 socks in the drawer. Right, 8 socks in the drawer, 5 are black, 3 are white. So the probability of her picking out a black sock is going to be 5 out of 8. And therefore the probability of a white sock is 3 out of 8. So I'm going to put that probability everywhere here. So it's going to be 3 out of 8. It's going to be 5 out of 8. It's going to be 3 out of 8. Work out the probability that the 2 socks are the same color. So that's my outcome here. So I can get black, 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 white, white, black, or white, white. So I can have here, I'm looking for the probability of it being black, black, and or the probability it being white, white. So the probability of being black, black. So I multiply the probabilities when I move along my tree diagram. Right, so it's going to be 5/8 times 5/8. Right, 5 over 8 times 5 over 8. That'll be the probability of black, black, which is 25 over 64. So 25 over 8. 5 over 8 times 5 over 8 equals 25 over 64. And the probability of white is going to be 3 over 8 times 3 over 8, which is going to be 9 over 64. So probability of black or white. So I can add these together. These are mutually exclusive events because I can't get 2 black socks and 2 white socks. So it's going to be 25 over 64 plus 9 over 64, which is equal to 36 over 64. And does that break down? It does. That breaks down to 9 over 16. So the probability of getting 2 socks the same color is 9 over 16. And finally, the last question here. This is an exam style question. A football team has 2 matches to play. The probability they win is 0.6. The probability that the team draw is 0.3. Complete the tree diagram. So they could win, draw, or lose. So 0.6 the time they win, 0.3% they draw. Therefore, they lose 0.1% of the time. And they don't say anything about that probability changing. So that continues on for the second match as well. So they win 0.6, draw 0.3, lose 0.1. Win 0.6, draw 0.3, lose 0.1. Work out the probability that the team will win exactly one match. So let's list all my outcomes here. So they could win, draw, or win lose. They could draw win, draw lose, or they could lose win, lose draw, lose lose. So I need to now work out the probability of win, draw, win, lose, draw, win, and lose, draw, win. So they at least... Oh, sorry, exactly one match. It says exactly one match here. So exactly one. So actually, we're not even including the first one here. Win. So what's the probability of win drawing? That is going to be 0.6 times 0.3, which is 0.18. Win losing is going to be 0.6 times 0.1, which is... Oh, good. 0.6. Yeah. 0.06. Where draw win is going to be 0.3 times 0.6, which is 0.18. And then lose win, which is 0.1 times 0.6, which is 0.06. I don't think I'm missing one. So, gorge. So, they win exactly one match. So, they win exactly one. So, remember, it's a probability they win, draw, plus the probability they draw, win, plus the probability of lose, win, plus the probability of win, lose. So, add all these probabilities up. So, win, draw is equal to... So, 0.18 plus 0.18 plus 0.06 plus 0.06. They are just the numbers I calculated up here. Add all of them up. So add them all. 0.18 plus 0.06 plus 0.06. 12 over 25. That's the probability of winning exactly one match. Anyway, I'm done this video now. That was a bit of a doozy. So, hope this was some help. I know it's kind of rushing through it, but girls, I'm tired. And I'll catch you later. Okay, bye.